Okay, so we talked about linear functions already. So a linear function is a function where the data points lie on a straight line, meaning that there is a constant rate of change between the independent and the dependent variables. So we defined this yesterday. Now, all that's new here is some notation, which you may have seen in science. That triangle really is the Greek symbol called delta. So delta y over delta x is how we say that. We use it a lot in science, and we use it a fair bit in math, especially if you go up to calculus, because calculus is a lot about rates of change. But that symbol is a fast way of saying change in y, rather than saying the words. Okay, so take a look at these two examples here. So for the first function on the left, the independent variable, so always we look at the vertical. I mean, yes, it could be rotated differently, but you need to look at what depends on what. And usually we show that vertically. So the cost, independent is the number of texts n, and dependent is the cost c. So this is dependent on this, so that's independent. For the second, so again here, dependent, independent. So the independent variable is time, and dependent is amount of fuel, which we used capital A. Just always look at what the labels are. Determine the rate of change of each of the above. Provide units with your answer. So this is a review from yesterday. So we looked, I always chose the first two, starting from the leftmost or the vertical axis. And I looked to see the change in y here. So you have to kind of look closely at what I'm just going to erase that just to see better. You can probably see better. That's at 25, and this looks like at 20. So it's the change in cost is 5, and across is 50 texts. So the rate of change is up 5, to the right 50, and reduce that. Now that would be 1/10. And remember, this is money. So this is dollars, and this is texts. So let's show this, because it's money, in decimal form. So it's 10 cents per text. And that's what it used to be in the old days when texting cell phones came out. It was by text. Some of you would go broke these days. Yeah, well, maybe very beginning, but some of you would go broke if it was by text, so, or by character. So provide units with your answer. We did. Second one, rate of change. So here, notice how the amount of fuel is decreasing. So when I look between those two values, those 2 points, I'm going down 10 to the right 2. So it's negative 10 over 2, which is negative 5. And what is that? That's liters per hour. Okay. So it uses 5 liters every hour, exactly. So take a look. The rate of change was positive here, and it was negative here. So any graph that's going up and to the right is always going to have a positive rate of change, and we're going to soon start calling that the slope of the line. Anything that's going down and to the right has a negative rate of change, always. So you should be able to just look at a graph and know if it's positive or negative. So for the first function, as the independent variable increases, the dependent variable increases. And the rate of change is a positive number. Right? So as the x increases, the y increases, so this is a positive rate of change. Next one, as the independent increases, the dependent decreases. So this is going down for every increase in independent. And so it ends up being a negative number. Anytime you're going down, that is on a graph from the left to the right. So if you're going down and to the right, that's decreasing. It's a negative value. Okay, so then the mathematical word that we use is slope. Slope is the same as rate of change. It's even easier. It's one word. Okay, and it often uses a symbol of M. So get used to it. You're going to be using that for that whole booklet that you have. Okay, 2 units. So slope is the rate of change, and it's the letter that can be used for it is M. Okay. So the change, another thing to think about, the change in the dependent variable is called the rise. That's vertical. Okay. And the change in the independent variable is called the run, because we can run horizontally, right? So another way of abbreviating this is rise over run. Not abbreviating it, but calculating it. So what's the rise and what's the run? Going from left to right. Okay, phones away. So here the change in the y is the rise and the change in the x is the run. This has a positive slope. Here from left to right, we're going down and to the right. That has a negative slope. So always start from the leftmost point and think about the rise. Does it go up and over, or does it go down and over? And then you won't run into any problems. Sometimes students take a point on the right and then figure out how to go left, but it messes them up. Think about reading a book. You read a book from left to right. So look at a line. Start from the left. How do you get to that point? You go up and to the right. Here, left to right, you go down and to the right. So there it all is again. All of the different ways of showing it. And then here, letter M can be used for slope. Okay. So now let's do some figuring out of slopes. So sometimes we talk about slope for application questions. For example, the steepness of a ramp. So anytime you have a ramp, there's certain guidelines. If the ramp is going to be used for a wheelchair, it can't be too steep. There's actually building codes for that. So it has to be a certain slope. Or have an angle in there of a certain angle, which will give that slope. And when we get to trig, we'll do it that way as well. Trigonometry can solve it. If it's an application question, then we always do it as a positive value. Because that ramp could be facing that way, but then if someone was standing on the other side, it would look like it was going downwards. So for applications, we always consider, that's recycling. Could you put it in the blue? So you always consider it to be a positive slope. So here, the slope, I'm going to abbreviate it with M, is rise over run. And so that's 4 over 17. Okay? Don't find the decimal form. Just leave it as a fraction. Put it in lowest terms if you can, but this one is already in lowest terms. There are no units for slope because you're taking the same unit and dividing by the same unit, right? So those units divide out. Now, if this was measured in meters and centimeters, we would have to change them to be the same unit in order to calculate slope. Okay? But we don't put any units for it. Next one is a 5-meter ladder, leans against a building, reaches up to a height of 4 meters. What is the slope of the ladder? Okay, so the slope of that, we need rise over run. rise is 4, but we do not know what the run is. We need to know what the horizontal distance is. Okay? Well, it's a right triangle. How do we find a missing side of a right triangle? Pythagorean theorem. I'm going to call that x. So then x squared is the hypotenuse squared minus the other leg or side squared. So x will be the root of 9. We'll keep just the positive root because negative doesn't make sense in this diagram. So x equals 3. So the slope will be 4/3. Again, no units. The only time we'll show it as a decimal is in application questions, or maybe in a numeric response, we might say round that to the nearest hundredth or something like that. Right, so those are a couple of application questions. Now we'll look at some line segments on a coordinate grid. Okay, so for the graphs below, we're going to find the slope. Notice how it says, for slopes of line on our Cartesian plane, we need to distinguish between positive and negative slopes. Application, they're always positive. On a XY axis, positive or negative. So the first one, thumbs up if it's positive. Good stuff. B, thumbs up if it's positive. Thumbs down if it's negative. Right. Because just take a look at them. Always have that in your mind. What's positive, what's negative. This from the leftmost point, I have to go up and to the right. Okay, so count up. Make sure you look at the scale. That's going to be up 5. To the right, 7 plus 5 is 12. So slope equals 5/12. This one, from the leftmost point, I've got to go down and to the right. So I'm going down means negative, and then to the right, 5 plus 5 is 10. So I chose the endpoints. You don't have to. You could choose any two nice points. Always choose grid crossings. If you don't, you may be estimating too much. But in any case here, if I reduce it, I will get -1/5, which if I change to do this triangle would be the -1/5. Okay, so always reduce it. Take a look here. I can't even make a triangle, right? It's a horizontal line segment. From the left to the right, am I going up at all? No. So my rise is 0. My run in this case is 12. What's 0 divided by 12? 0. So slope of a horizontal line is 0. Memorize it if you need to. Okay? Slope of a horizontal line is always 0. Vertical, okay, so here my rise is what? It's going from -3 to +3. So that's 6. My run is what? 0. It's not going anywhere horizontally. Can you divide by 0? No. So this is undefined. So any vertical line has a slope that's undefined. They used to in some textbooks say it had no slope, like the word NO, but then people kind of got confused with 0 slope, because sometimes nothing or no slope, they might think it's 0. So now we just say undefined, and then it's understood. Okay, you can't divide by 0, so the slope is undefined. So for examples A and B above, the line segments are called oblique because they're diagonal. Oblique line segments are line segments that are not horizontal or vertical. The slope of an oblique line segment could be positive or negative. Without doing any calculating, how can you determine just by looking at an oblique line segment whether the slope will be positive or negative? Well, we'll have a positive slope if it goes up and to the right. between any 2 points. Okay. Negative if it goes down and to the right. For a line that's horizontal, the slope will always be, as I said, always be 0. And for vertical, it will always be undefined. Okay. So that's looking at graphs. Well, we'll do a little bit more, and then we'll get into an actual formula that you can use, so that if you don't have the graph, you can still calculate the slope. So to calculate the slope of lines on our Cartesian plane, here are the steps. Choose 2 exact points that are on the line. So in the last page there, these ones were actually line segments. So they were nice endpoints, easy to find those points. Now these are lines. So you have to look a little bit closer to find some nice points. Take a look here. This looks like a nice point. And this one. The intercepts are always kind of helpful because sometimes they're nice values, not always. But in this case, they look pretty good. So I've chosen to count the number of units that you move up or down, and then left or right. So here, I'm always starting from my left point that I choose. Between those 2, I've got to go up and to the right. So draw a right triangle. How many am I going up? 3. How many to the right? 6. So my slope is 3 over 6, which reduces to 1/2. Okay. Positive, makes sense. It's going up and to the right. All right, so then choose nice points. Here, the x-intercept doesn't look nice. The y-intercept looks pretty good. And this point looks good. You might use this point down here. I'll use these 2. So of my 2 points here, my left one, I'm going to go down and to the right, because I can't get there any other way if I'm going rise first. So then I'm going down 3 to the right 4. So now my slope is negative 3 over 4. Okay. So if you're given the graph, it's really easy to find the slope. Choose 2 nice points. Go from the left to the right. How do you get there? Down or up and to the right. You're always going to the right.
How do you find a nice point?
Well, you look for a grid crossing, where the line crosses the grid on the graph. All right, the next one, actually, we're going to graph some lines. So it says, draw the line that passes through the given point with that slope. Label each with its letter. So they're points. So always it's x comma y for an ordered pair. So -7, -2 is the point. And the slope is 5/4. So from that point, this means my rise is 5 and my run is 4. So I go up 5, 3, 4, 5, and to the right 4. 1, 2, 3, 4. Okay, I'm going to do that as many times as will fit into the grid. I'm going to do it again. Up 1, 2, 3, 4, 5. Oh, sorry. 5. To the right, 1, 2, 3, 4. And then join it up with a line. And I'm going to put arrows on the end because it says it's supposed to be a line, not a line segment. And that is line A. The slope should be the same. all the way along the line. If it's not, then it's going to not be a line. It's going to be wonky, right? So this one, 2, 8. So 2 for x, 8 for y. That's the same point as I have up there. But now my slope is -5. So think about that. What is -5 as a fraction? Which we rarely show, but it helps with slope. It's -5 over 1. So this is your rise, and this is your run. So now from that point, I go down 5 to the right 1. Then I do it again. 1, 2, 3, 4, 5 to the right 1. 1, 2, 3, 4, 5 to the right 1. Fill up as much of the graph paper as you can.
Why do you start from there?
Because it tells you to. 2, 8. That's what it tells you to do. I'm going to do it, oops, in a different color.
So from 2, 8, you go down 5.
To the right 1.
Oh yeah, you crossed over 1, 8.
Pardon?
You crossed over 1, 8. 2, 8.
Oh, did I? Oh, yes, I did. Okay, so do you think then, this is a good learning thing, I started with the wrong point, but if my line that I draw, will it be the same slope? Yes, so I can just move, if my computer works, that line over. Then let me redo, sorry, I started at 1, 8 instead of 2, 8. So I'll do it in red, 2, 8, down 5 to the right 1, down 5 to the right 1, down 5 to the right 1. Now if I move my line back, it should be right on there. Okay, and so my red, I'll put arrows on the end. Yeah, I didn't look closely because we'd already had that other point. I just saw the 8. Sorry about that. So that is my line B. Okay, but the slope, any line with the same slope is going to be parallel to each other. Okay, let's do the next one. 5, 4. So 5 for x, 4 for y. Slope of 0. Is it going to be horizontal or vertical? Horizontal. I'm just going to freehand this one. And then 7, -4 is undefined slope, so it's a vertical line. And I'm freehanding it, so it's not great, but it's a little bit faster. Okay. Okay, so now we're going to look at lines that, well, look at coming up with an equation so that we don't have to have the graph. You don't want to always have to have a graph to find the slope or the rate of change. Pardon me? It makes it easier, but you're not always going to have that information. So we have to be able to know how to do it without. Okay, so we're going to look at a general case here. So we've got a line. It might look like these points are on nice grid crossings. We're not going to use the values. We're going to look at going from the left point to the right point by drawing a triangle. Okay, and think about what the expression for the rise is. So this point here that forms the 90-degree, who can tell me what the coordinates would be in terms of x1, y1, x2, y2? What would be the x component of that point that's directly above? There's no 3's. x1, yep, because it's the same. This x value here is x1, so it's going to be the same there. And then all of these points have the same y value. So that's going to be y2. So now when we think about our rise here, we're taking the highest minus the lowest. So the rise will be y2 minus y1. Okay? Because we can't count them out. We don't know what the actual values are. So we go highest minus lowest. Then the run will be highest minus lowest horizontally. So that is another expression for the slope. Our rise will be y2 minus y1, and our run will be x2 minus x1. And that's the formula. Okay? Memorize it. You might be given it, but you should memorize it. And you can't get it mixed up. You can change which point you're talking, which point you're considering to be your first or second, but you can't do y2 minus y1 and then x1 minus y2. So the 2's have to line up and the 1's have to line up. So let's practice that. Okay? And we'll give you a formula sheet. We haven't had any formulas yet, but we'll give you one that shows you that you have it on there. So now we have 2 points. E and F. Doesn't matter which is your first and which is your second. I'm just going to go in that order. So this I'm going to consider x1, y1. And this will be x2, y2. So now my slope will be y2 minus y1 over x2 minus x1. The biggest mistake students make is with integers. So it's not 5 minus 3, it's 5 minus negative 3 in this case. So that's negative 4 over 8, which reduces to negative 1/2. And always reduce it. And then in 7, it says, use the same coordinates to show that the order that you subtract them does not matter. So now I'm going to go, I'm going to say my F is x2, y2, and my E is I'm going to say my E is x2, y2, and my F is x1, y1. So if I do that, then my E will be 6 minus 2 over negative 3 minus 5. So I'll get 4 over negative 8. Still, only one negative. In 6, it was negative 4 over 8. Now it's 4 over negative 8. Both of them reduce to 1/2. Negative 1/2. Okay, so order doesn't matter, but the formula does, that you are consistent. Okay. So, a bunch here to practice. Sorry. I'll do the first one, and then I'll let you work on the next few for a few minutes. Okay, so slope. This I'm going to consider as my second point, so point 2, and this is point 1. So y2 minus y1 over x2 minus x1. Notice how I put that negative in brackets so I don't mess up. So negative 11 over 8, and I'm done. Okay, you do the rest up to E, and then we'll come back at number 9. So there are the answers for B, C, D, and E. Take a look at D and E. So D, those 2 points, you've got negative 3, 7, and negative 3, negative 8. If we were thinking back to work from a few days ago, that would be 2 points that would not create a function, right? Because for the x value of negative 3, there are 2 different y values. So when we try to find the slope, it's going to be a vertical line, and that has undefined slope. Okay. Then if you take a look at E, we end up with a slope of 0 because the x's are different, but the y's are the same. Okay, so that means there are 2 points on a horizontal line. And the other ones, just reduce them to lowest terms. Last question is just to make sure you understand how you could find the slope by just being given the intercepts. So the line shown below intersects the x and y axis. The x-coordinate of the point of intersection of the line and the x-axis is called the x-intercept. So this 6 is the x-intercept. State the coordinates and mark it with a dot. So the x-intercept is 6. The coordinates of the x-intercept would be 6, 0. So if it just asks you for the x-intercept, you just have to give that number. If it says the coordinates of it, then you go 6, 0 in round brackets. And I've plotted it there. The y-coordinate of the point of intersection of the line and the y-axis, so that's this point, is the y-intercept. Notice how it's got a PT. It's not an intersect. That has a CT, where there's 2 lines crossing, but the actual y-intercept has a P in it. So the words are a little bit different, right? In any case, the value there is -4, and then the coordinates of that point would be 0 for x, -4 for y. Sometimes students get those mixed up. They put the 0 in the wrong place. Now, it says use these points to find the slope of the line. So, if we're using the slope formula, then we're going y2 minus y1. So I'm going to call this my second point, and this my first point. So this would be -4 minus 0 over 0 minus 6. So that simplifies to -4 over -6. A negative divided by negative is a positive, 2/3. And that makes sense from the diagram. It looks like it has a positive slope. So just be a little bit careful. If you were just to use -4 over 6, just thinking about the intercepts, you would have the wrong sign of it. You would say it would be negative where it should be positive. So best to use the coordinates or do a quick graph. Really, graphically, it's so easy because you're just going up and to the right. So up 4 to the right 6 reduces to 2/3. So you have it graphed, it's really easy. But if you're just given them, then just make sure you think about whether the slope is positive or negative. So here it says algebraically determine the slope of a line that has an x-intercept of 4 and a y-intercept of 10. So think about that, an x-intercept of 4 and a y-intercept of 10. Will that have a positive or negative slope? Negative slope, okay? But some of you will tell me that it's 10 over 4, which is 5 over 2, and that is wrong, right? Because you're just taking the intercepts. So if it says algebraically determine, then your 2 points are 4, 0 and 0, 10. And so your slope will be, you decide which is your first and which is your second point, but I'm going to use this as my second point and this is my first point. So I'm going to have 10 minus 0 over 0 minus 4. So 10 minus 0 here and 0 minus 4 here. So that's going to be it's going to be 10 over -4. We always show the negative out front or up top, and that's going to be -5 over 2. Saying that, you could use the negative in terms of a direction in calculating, like to graph slope, but we always show it with the negative out front. Okay, so that's where the lesson ends, and then you can see there are done practice questions, and then of course there are questions from